we have used the definition to determine the derivative. Now it is, as we can see, it is a long process, a long procedure. So we come up with rules of differentiation. There are many rules of differentiation. If you Google, you'll find 20 to 30 rules of differentiation. In fact, we are only learning two rules of differentiation here. And the first one, I call it as power rule. What is a power rule? For example, let's say here y is equal to, what the power rule states, y is equal to x to the power of n. Y is a function of x and x is in powers, in exponent. Here n is any real number. Here n is any real number, not only integers. It can be any real, it can be 1, it can be 2, it can be -5, it can be 1 over 2, it can be root 3, any number. X is any real number. Now dy over dx is equal to n times x to the power of n minus 1. That's the first derivative. Let's observe now very carefully here. Y is equal to x to the power of n. And first derivative is n, the x power comes to the coefficient, and I reduce the power of x by 1. So this is how we write the derivative. So this is a rule of derivative, and we call them as power rule. Again, if y is equal to say k times x to the power of m, then dy over dx. Here y is a function of x. Y is a function of x, and k is a coefficient of x to the power of m. K is a coefficient of x to the power of m. K and m are real numbers, but they are constants. We call them as parameters. Here, so what will happen here is m times k, x, I reduce the power by 1. So that's how we differentiate an exponent. So this is the only rule that we are learning here. The second rule is, now the second rule here is called the constant rule. Constant rule. If y is a constant, y is equal to k, where k is a constant. Then y does not change, therefore dy over dx is equal to 0. X may change, but y is not changing. Therefore, y is a constant. Therefore, there is no change in y. Therefore, derivative is equal to 0. So what we now going to do in here is we'll apply these two rules, a combination of rules to derive. We must be very fluent in algebra, very fluent in rules of exponents. Let us now see here. I have a question here. F of x is equal to 5x squared minus 3x minus 4. Determine f prime of x. I have to find the first derivative. How I find the first derivative here is my f of x is equal to 5x squared minus 3x minus 4. Now I am going to apply the rules of differentiation here. So I take term by term. I apply the rules of differentiation in terms. There are 3 terms here. So I apply the rules of differentiation first term, in second term, and the third term. Now look at the first term here. If I look at the first term, it is 5x squared. Therefore, the power here is 2 and my coefficient is 5. So what I'll do here is I will write 2 times 5 x, and I reduce the power of 2 by 1. So what is happening now here is, if you observe very carefully here, what is happening? The coefficient is the power is becoming the coefficient. The power is becoming the coefficient, and the power is reduced by 1. The power of x is reduced by 1. Therefore, if there's already an existing coefficient which is 5 here, so I'm multiplying with the existing coefficient. So it's 2 times 5 x to the power of 2 minus 1. Then again next is 3, negative 3x. So I put this negative as it is, and this is negative as it is, and then 3. The coefficient is 3 now. Now x, the power of x is 1. Therefore I bring that 1 here, 1 times 3, and x to the power of 1 minus 1. Then next is the 4. 4 is a constant, and therefore I write 0, I write minus 0. So now I simplify it. Now my differentiation is over. I will not differentiate again. My differentiation is over, my first derivative is over. And now it's simplification. It's 2 times 5, it is 10. And x, 2 minus 1 is 1, which I don't write the 1. And is 1 times 3, which is 3. And x to the power of 0 is 1. Therefore, I write 3 times 1. And negative 0, of course, I can ignore that one. Therefore, my final answer is x, 10x minus 3. Let's take here another example here. Y is equal to 2x minus 3 to the whole squared. I have to find the first derivative. I have to determine y prime. So my y is equal to 2x minus 3 the whole squared. Now here we must have in separate terms. That means I have to first simplify this in exponential form. Therefore, I'll use my rules of rules of algebra, which here it is the FOIL method, and I apply the FOIL method here to simplify this 2x minus 3 the whole squared. So here this I apply the FOIL method here, which will become now 4x squared. Then 2 times negative 3 is negative 6. Again negative 6 will give me, let me write negative 6, and again negative 6, and then positive 9. So I apply the FOIL method here. So which is very important. So you must be very solid understanding of the algebra. Now this is my simplification. I simplify, I use like terms, and I get this one. 4x squared minus 12x plus 9. Of course, you can straight away, if you are very comfortable in algebra, you can straight away write from the first step to this step. But you must be very comfortable. Now I have to find from this, I have to find the y derivative. So I write y derivative is equal to 4 times 2. I am simplifying, I am reducing the steps here. So I can say 2 times 4, which is 8. So I have 8 here, and reduce the power of 2, the 2 minus 1, which is equal to 1. And we don't write that. Then it's 12 to the power of x. And it will become 1 times 12, x to the power of 0, which is 12. Therefore, I write here 12, and other one is 9, which is 0. So this is my final answer. Don't derive again and write 8x and make it 12 0. Many learners make that mistake. So my final answer here is 8x minus 12. Another question here. Here's y is equal to x square minus 3 over x. Find dy over dx. So here, this is not in exponential form. So I'll write this in exponential form first. So that is my first step. I must write in exponential. So I apply the laws of exponents. 3x to the power of negative 1. I will change only x. I will not change anything with the 3, which is a constant. So this is my first step. Write in exponents. Then I apply the rules of differentiation to each of these terms. So here, this 2 will come to the coefficient x, and I reduce the power by 1 minus, again, it's 3 times negative 1. My exponent is negative 1, and I reduce the power by 1, that is minus 1, minus 1. Reduce the power by minus 1. Now here, then comes here 2x minus this negative 3 times positive negative 1 will give me positive 3, x to the power of negative 2. Yes, I am done with my answer here. But if the question is write in positive exponents, then I will change the negative exponent to positive exponents, applying the rules of exponents. Again, when very careful here, the 3 must remain in the numerator. 3 is still the coefficient. So this is how we do it here. So first thing, important thing is to have in the function in exponents. And then we apply the rules of differentiation, the x power rule of differentiation. So we must be very careful here. If there's a minus, minus into minus becomes plus. We don't do anything with the 3, the coefficient here, 3. 3 remains as the coefficient. 3 is a coefficient. It 3 remains a coefficient. Here the next question here is dx of 3 over 2x minus cube root of x squared minus square root of x to the power of 5. The question here is find the derivative of this expression. So that is the question. So dx is another notation of the differentiation. So here now let's see here how we are going to simplify this now. It is now dx. I am simplifying the expression. I am not deriving it. So when I simplify the expression, I'll use a notation dx of. Now here 3 over 2 x. X is in the denominator. I take x only to the numerator. So it is x to the power of negative 1. Minus x to the power of, I write this radical form in exponential form. Again, x to the power of 5 in insert form, I will write x to the power of 5 over 2. So the key understanding here is 3 over 2 is my coefficient. I will not take 2 to the numerator. The common mistake most of us make. So it should be 3 over 2. 2 should remain in the denominator. I'm taking only the x. So only I change the power of only of x to the power of negative 1. Now I have simplified. Everything is now in exponential form. Now I'll start differentiating. When I start differentiating, I write dx is equal to, which is very important, 3 over 2 x to the power of, I reduce the power by 1. Before that, I forgot to bring the coefficient down. So it's 3 to the over 2 times negative 1 x to the power of, I reduce the power by 1, minus 2 over 3 comes to the coefficient x to the power of 2 over 3 minus 1. Next is 5 over 2. The power is 5 over 2. I bring that 5 over 2 to the coefficient times 1. X to the power of 5 over 2 minus 1. Now my differentiation is over. Now what I'm going to do, I'm going to simplify it. So is equal to is negative 3 over 2 times x to the power of negative 2 minus 2 over 3, x to the power of 2 over 3 minus 1 will give me negative 1 over 3, minus 5 over 2, x to the power of 5 over 2 minus 1 will give me 3 over 2. So something I want to emphasize here is that the second step is my derivative. I apply the rules of differentiation here. This is simplification. The third step you can see here is my simplification. I did not do any I did not apply any rules here of differentiation. I apply only the rules of exponents. Now this is my final answer. If we want to write in positive exponents, then we can write in positive exponents, which is 3 over 2 x to the power, again it is 3 over 2 x squared minus 2 over 3 times x to the power of negative 1 over 3. You can write in a radical form if you want to, 5 over 2 x to the power of 3 over 2. So this is in positive exponents. The question here is f of x is equal to x squared minus 5x minus 6 over x minus 6. Determine, find f prime of x. Here we will not be able to apply the laws of exponents because there are two terms in the denominator. What we'll do here is first we'll simplify it. That means I'll write my original expression here, x squared minus 5x over x minus 6. Here, how I'm going to simplify is I'm going to factorize it. So here is very important that you are very strong in algebra, in factorization here. So here x squared minus 5x minus 6. So I take the factors of 6 with negative 6, which is negative 6, and positive 1 will give me a difference of negative 5. So it's x minus 6, x plus 1 divided by x minus 6. Now this x minus 6 I can actually cancel out, right? It's because of that I reduce my expression to x plus 1. So here my key here is factorization, which is very key here. So that I simplified. Now I got the simplified expression, then I'll start differentiation. Now I'll start my differentiation. F prime of x is equal to differentiation of x, which is 1 times x to the power of 1 minus 1, which will give me 1, and the other one is 0. So I'll stop here. Don't try to differentiate again and make it 0. So f prime of x is equal to 1.